Hello everyone, myself Sanjana Chaubey, and today in this video I am going to explain our major project VisionMate, that is AI-based digital guide for visually impaired individuals. Our team members consist of myself Sanjana, Sanjeev Desai, Sanika Jadhav, Ashish Kumar Mourya under the guidance of Mrs. Pooja Vakre. Now let us try to understand our problem statement. Visually impaired individuals significantly face many challenges in their day to day life. In recognizing simple objects, reading simple text, understanding real time environment, it seems very difficult for them to carry out this much activity into their day to day life. Though there are various assistive tools which are available in existence like white canes, guide dog, and simple basic mobile applications as well. But these solutions often provide limited functionality. It lacks real time adaptability. Existing systems may offer isolated features like object detection or text to speech, but they are not often integrated into a single user friendly platform. So there is a need for an intelligent or real-time and accessible guide that uses AI, computer vision technologies, NLP processing that can assist visually impaired individuals in navigating safely. Now let us try to understand our proposed solution. Our solution VisionMate is a smart AI powered wearable assistant that will be acting as an intelligent agent, enabling visually impaired users to interact using voice and get real-time audio feedback guidance through Bluetooth. Our entire system is modular in architecture, and some of the intelligent modules are listed below. The first one is currency detection module, in which the user will show the currency which he or she will be having, and our system is going to recognize that currency and give the output in the form of an audio via Bluetooth. Second module, we have reading module, through which we can user can read the documents, boards and labels which can be extracted via VLM model. Third, we have scenario description mode, in which scene understanding and narration will be done using Groq LLM. And lastly, we have most important module. And fourthly, we have navigation module, which will be giving real-time obstacle detection and which will be guiding the impaired individuals to take the instructions carefully and they can navigate safely. For that, we have used YOLO version 8 and MiDaS module. And each module delivers audio feedback through earphones, which enables hand-free and real-time guidance. Now let us try to understand the system architecture. So as we can see, there will be one user which will giving the input in the form of a voice or gesture. Now that voice will be passed through our voice assistant, which will convert the voice into text. Once this conversion is done, it will be gone into the next stage, that is intent recognition. So for example, we can take an example like a user describe like I want to read a document. So if the user says that, this speech is going to convert it into the text and it will be recognized by our main orchestration framework, that is LangChain. It is going to recognize the intent. Like the user says, I want to read some document. So definitely it will go to the reading module. Once the module is get selected, the camera gets on, it captures and it executes the following module. For example, in this scenario, we have taken the example of reading module. So reading module will get executed. So this comes under the entire AI processing module. Once the structured response generated, it get passed through it get passed through Whisper API. Again, text to speech conversion will be done, and we are using ElevenLabs API for voice, for speech synthesis, and then that output will be come in the form of a audio. So this is the entire system architecture. Now let us understand the dataset description. So in this entire project, we have mainly used two datasets. So now let us try to understand the dataset in more detail. So for currency detection module, we have used a dataset named Indian currency notes from Kaggle, and we have annotated, pre-processed and optimized that dataset on the platform Roboflow. Then the detection model was created by fine-tuning this dataset on the YOLO version 11 model for increasing the speed and accuracy in real-time detection tasks. This is some of the images from the dataset I have taken. Another dataset which we have used, it is for object detection model, obstacle model. The dataset named obstacles in public spaces for Dist-YOLO. Now this dataset consists of 3,350 real-world images which has captured through public environments, and this entire dataset includes 15 different obstacle classes which are commonly available around our surrounding, such as puddles, potholes, stairs, poles, etc. Now for the model development, we have used a YOLO version 8 architecture, and we have fine-tuned this dataset again on this model with limited data. And we have trained this model for 50 epochs. And lastly, we have used ADAM optimizer, which is applied on this YOLO detection loss function, ensuring more accurate detection in real-time scenarios. So this is some of the dataset images which I have taken, and this is the output after training. As we can see, bicycle, person, everything got detected, and it is written in the form of a text and coming in the form of a voice output as well. Now let us dive into the hardware design. So whatever we have understood till now, we have discussed till now, it includes the software part. Now this entire software part has been integrated into this small green color part, which is a microprocessor, namely Raspberry Pi 5. So the entire software module is integrated into this part, which is acting like a mini computer for us. Then on the top of that, we have Halo 8 AI hat NPU, which is acting like a AI layer on that. It enables the microprocessor to handle AI models more accurately. And lastly, we have Raspberry Pi Camera 3, which is going to capture the entire surrounding and give the output accordingly. So this is the simple design of hardware. Now, as we have already discussed that our entire software is a modular architecture, so I have tried to explain one module, as we have a lot of modules in this software. So I've tried to explain one of this module, that how it is working. So I have taken the example of scene module. As you can see, this was our dashboard before. So it is always listening. So I have said describe my surroundings, so it's got converted into text. Now this scene got captured and output got in the form of a voice, and also in the AI response to show whether the output which is generated is correct or not. So this is how the module gets work. This is one of the model explanation I have shown. There are various modules also there. This is the results and outcome. As I have discussed, there are various modules present: scene navigation, obstacle, currency, text reading, voice assistant. Along with that, whatever method we have used, evaluation metrics, accuracy and latency has been completely defined under this table. For example, we can take an example of currency recognition. As we have discussed earlier, we have fine-tuned Indian currency node dataset on YOLO version 11 model, and for the evaluation metrics, we have used mean average precision, which gives us the accuracy of 96.3% and the latency of 41 milliseconds. So this is how we have listed down all the modules along with their accuracy and latency. In the conclusion, I would like to say our entire project demonstrates that how an AI-based assistive system can help visually impaired individuals in their day-to-day life to carry the simple tasks like reading text, recognizing the surrounding, carrying out simple tasks. Our entire goal was to make their task easy, and overall, the solution highlights the potential of accessible, cost effective AI technologies which can improve the quality of visually impaired individuals while maintaining practical usability. Thank you.